as practitioners in building science, as weatherization folks, we're looking at everything as a system. The whole home is a system. And that fundamental knowledge translates really easily in other settings, like, this light commercial, because realistically, we're still dealing with forced air furnaces. We're dealing with a similar ductwork. We're dealing with conditioned, unconditioned zones and all these other things. That it's the next step up in terms of the scale of these projects.
Welcome to the Flow Lab, the podcast where we dive deep into the science of building performance and HVAC innovation. Today we bring you another insightful episode aimed to enhance your knowledge and expertise in the field. Joining us are your co-hosts, Ben Walker, co-CEO of Retrotec, and Sam Myers, a renowned building science specialist and Retrotec trainer. Together, they bring a wealth of experience and knowledge to ensure our discussions are both informative and engaging. So, sit back, relax, and get ready to enter the Flow Lab, where we'll explore the world of building performance. Let's get started.
All right. Well, welcome everybody. My name's Sam Myers. I'm with Retrotec. With us, we have a couple of guests from CETA. We've got Dan and John here with us. And the topic we're going to talk about is weatherization and commercial construction. And we did a project, was it last year when we were in that blower door test?
July,
Yeah, July of last year. It was a firehouse, and it has been having some issues for basically since it was built around year 2000.
That's right.
High humidity. There's a bunk room where the firemen sleep. They were staying sick. So there was all kinds of problems. Other contractors have tried to come in the past and make changes. Nothing really got any better. So we ended up running some testing on it. But Dan, I'll let you kind of give us the rundown on how we kind of got involved with this and where we went with it.
Yeah, thanks, Sam. So I'm Dan Maxmew. I work for CEDA in Chicago. We are a community action agency, but this was one of those kind of unique things based on my experience and my passion for diagnostics. I was happy to take this project on. Sam gave us a kind of a call and asked if we were willing to go out there and help do some testing. But realistically, the project ended up being an envelope issue. So really, there was no lid on the building, so to speak, right? That's in kind of the short version of what was going on there. But lots of HVAC contractors had gone out there and try and deal with the symptoms, right? Dealing with the moisture load, kind of dealing with some of those issues, and changing equipment, putting in dehumidification, doing all this stuff. But really, there was no one ever really addressed the envelope, and no one stopped to think about that. So, they've been dealing with this problem for the last 20 years. It had gotten so bad at some point where wallpaper was peeling off the walls. And so they had all sorts of stories and history living there that they were able to share with us. And so once we made contact with them, John and I went out and took a look. And then we ended up doing kind of more of a forensic building audit for them to try and just determine the root cause of the issues and provide a report for them, which included doing kind of a whole building or an envelope test on that project. And we can kind of get into the details on that. But, we ran a bunch of fans and couldn't get a number, basically, is the way that ended up working out. So it was a fun project for us to get involved in. And it really kind of allowed us to leverage our skills as a weatherization agency and having all the experience doing years of retrofit work, just kind of in a new market, which was really the fun part about it. Add to it, Jen?
I think that we're always kind of connecting with partners and looking for these type of opportunities. When we look at the environment that we work in as a community action agency, right, we're always trying to say, how do we remain sustainable outside of the federal funding that's available, and through the partnerships of attending these conferences. And we are a Retrotec equipment user at a very large scale. And so, this kind of partnership made sense to, come together and address some issues that we're really facing, health disparities for the firemen that were in the firehouse. And frankly, a taxpayer issue, because they kept throwing money at HVAC contractors who, as Dan pointed out, kept trying to add different equipment versus really understanding the science of what was happening.
Yeah, so I remember this project originally came across my desk. one of my industry colleagues was walking through and kind of got the gist of what was going on, but he called me and said, "Do you know anybody who does commercial blower door in Chicago?" I thought about it. No one really came off the top of my head. I was like, "Well, I know who has a bunch of fans, and they know building science, right? They know what makes buildings go wrong." And I don't know if folks in the weatherization industry realize this, but commercial blower door is its own industry. It's massive. And the projects are at a different scale. They cost a lot more, right? So they pay a lot more. And really, the only difference is between going from residential to commercial is learning how to network multiple fans, multiple manometers together, and using the software to run everything and getting all of your data from one spot and generating that report. That's really the only learning curve there is going from residential to commercial. And so knowing that they had everything else that they needed, I was like, there's no reason why these guys can't go in and do this because it's an existing building. The other thing about this is when we see a lot of large building tests done, it's usually to meet code, right? So they're doing new construction. They're not figuring out why something went wrong. They're just there to prevent something from going wrong. And that's a lot easier to do because you're there from the design phase all the way to when it's completed. But when things go wrong, now you have to go hunt down and figure it out. And weatherization agencies do this every day. Right? That's nothing new. The physics are still the same. You get stuff below dew point in the humid environment, it condenses and it grows mold. We know that. So there's this interesting kind of gray area between residential and large commercial, and that's existing light commercial, right? So those are projects that are, maybe a little bit bigger and a little more complex that your typical weatherization agency is used to, but it's not big enough where these big engineering firms want to take them on. Yeah. So I think it's a really good opportunity for weatherization agencies to kind of just learn these few extra steps and apply the same knowledge that they already have to everything else. But that's exactly what you guys did here.
Yeah, and I can talk a little bit more, kind of give you an idea of what the project looked like, right? The construction of the building, yes, it was built like a commercial building, right? The firehouse actually has 2 offices that are divided by the apparatus bay where all the equipment is, the garage space, whatever you want to call it. And the residential side, it was basically just a CMU block wall. It's a masonry wall. They have steel roof truss for the whole architectural roof. It's not a flat roof. It's an actual pitched roof on top of this building. So realistically, if you were standing in the attic, it looked very similar to what we're used to seeing in residential homes where, but it's just steel truss, right? Everything is built with commercial materials versus residential materials we're used to, wood and that sort of thing. But, so inside the living space, one of the other major differences that we encountered is that, it's 8-foot ceiling and then there was a suspended ceiling, an ACT, acoustical tile ceiling. And then above that, there's a 3-foot mechanical chase that ran throughout the whole space. And then above that mechanical chase, what the builder had done is just put in FSK or foil scrimcraft paper that was not taped or sealed in any kind of way. It was just fastened to the bottom of that roof truss, right?
And falling down in a lot of places.
Falling down in many places. And then they just laid bad insulation on top. So essentially, there was really no cap on the building, right? That FSK was not providing any kind of moisture barrier or anything. It could have been if it was installed intentionally, but it was really just put in to hold the insulation in place. So realistically, that whole living space and in that mechanical chase kind of being a buffer zone almost with that ceiling system in there, that drop ceiling system in there was basically just open to the attic. And there's just no separation at all. So that was, we went in there and we did the full audit, but really it took us 5 seconds to realize what was going on, right? The condition of that FSK was falling down. Some of the bats were falling down. All of the duct wrap, the duct insulation wrap that was running through the space that you kind of would see in a commercial setting, was also saturated due to all the condensation and everything. So, there's just kind of these things just built on top of each other, one after the other. And the thing is that this topic has come up quite a few times as we've been in different sessions, but kind of connecting the dots between HVAC and envelope work, right? And making sure that, those go hand in hand. Well, on the commercial side, I would almost say that there's more of a divide between those things than there even is on the residential side. Yeah. So these are commercial HVAC contractors that are coming in used to looking at complex systems, and they're really focused in on solving the problem that they've been given to solve, not necessarily looking at other problems. And I think that's one of the skills that as practitioners in building science, as weatherization folks, we're looking at everything as a system. The whole home is a system, right? And that fundamental knowledge translates really easily in other settings, like this light commercial, because realistically, we're still dealing with forced air furnaces. We're dealing with similar ductwork. We're dealing with conditioned, unconditioned zones, and all these other things that it's just kind of it's the next step up in terms of the scale of these projects. Really, I mean, it's not really all that different than what we're dealing with on a regular basis. So, Sam came out and helped us run a test. We threw up 6 fans and couldn't get a number at all, right? Which is no surprise, because the footprint of the space is, of the living space is right around 5,400 square feet. So it's a pretty big space. Most of it all open to each other. It's got all the regular stuff: living room, kitchen, bunk room, bathrooms, a gym, some other accessory rooms. But in that space, we couldn't get a number. Yeah.
Well, we could in one direction.
Oh, that's right. Yeah. Depressurized.
So remember, like a lot of this, maybe about half of the ceiling was ceiling tile, right? And that was the biggest problem.
Yeah, the rest was drywall.
Yeah, the rest was drywall. But the ceiling tile was like the effective air barrier that we could test. So there is a little bit of a difference in how you interpret leakage when you test commercial buildings versus residential. What we're used to in weatherization is ACH 50, right? Where you need the volume of the structure to calculate that. In commercial, what we look at is the total surface area. So we want the CFM per square foot of envelope area. So instead of using the volume, we use the total surface area, because air leaks through surfaces, not volumes. So it's a more accurate way to interpret that leakage. So in commercial, ACH isn't a thing. It's not used, because when you have buildings of different sizes, ACH doesn't really put them all on a level playing field. So that's what we had to go by. And just to give you a point of reference, maybe one standard that's been used for quite some time, the Army Corps of Engineers has their air tightness standard, and it's okay. It's not super tight, but 0.25 CFM per square foot of envelope area is what's allowed to leak for buildings of that standard. This one was what?
Oh, I think that we were like 5 or 6.
Well, I think it was like 0.25 would be like a pretty good building, but I think this was like 1 point something.
Yeah, 1.7 or something.
Yeah, so it was pretty intense. And the other thing too, in commercial, what we want to do is what most of the standards require us to do is test in both directions. So you want to depressurize and then flip fans around, and then also pressurize and collect that data too, because the building's going to leak a little bit different in both directions. Well, when we kind of knew this was going to happen, but we went for it anyway. And so we flipped the fans around, and no, I mean, we lifted up some ceiling tiles, like, okay, this FSK that they put up, let's see if it holds up, and it did not.
We even lifted ceiling tiles after opening ceiling tiles up in the ceiling. So it just kind of that much air was moving through that, it just wasn't feasible. It was an interesting project. So after we did all the testing, provided a report, they asked for some recommendations on, how to address the issue. And, obviously we're not an engineering firm, right? So we had to be careful about the way that we did that. And we gave them some suggestions. They vetted that. And they used that recommendation in their scope of work when they bid this job out. So they actually put the job out to bid. Finding a contractor in this space was a whole nother fiasco for them. That was quite an interesting thing, because you can imagine that, it's very niche for the home performance contractors to be working on retrofit jobs, right? And that's most of the contractors that do it are at this conference, right? And on the commercial side, I think there's absolutely nobody that does this on the retrofit side. So, we talked about how agencies can kind of, move into a new market space and kind of generate some revenue that way and leverage the skills you have grow, but the contractors also have that same opportunity here. So we ended up getting brought on as the QA/QC consultant as the work was being done, and working with the procured contractor to kind of verify that the air barrier was being installed correctly and that sort of thing. But we ended up also being the trainer and the the specifier of the materials and all of the other things, just because we had to teach that contractor who was used to doing commercial work how to do this kind of air barrier install work. So, and there are air barrier contractors out there that specialize in this. But again, this project no one wanted to touch, because in that mechanical chase where all the electrical was running, all the sprinkler lines were already in place, all the ductwork was in place, and everything was in the way. And it had to be all dropped down, and we had to find a way to bridge over the top of existing partition wall top plates and stuff, so that we could actually get the detail to make sure that we were getting a consistent air barrier across the ceiling and not just compartmentalizing the rooms room to room. So it was a unique challenge. But again, these are all skills that I think that many of us in the industry already have. It's just applying them in a different way.
Yeah. I think some of the precursor, like we talked about, like when we first walked in, I think they had some digital humidistats, right? It was reading like 77% humidity.
Yeah.
And this was room. In the living quarters, right? For the firefighters, specifically where they slept. And this was in the winter.
Yeah.
This wasn't even in the summer when it was reading humidity that high, right? So when Dan had prefaced, like, the wallpaper was coming off the walls, and the other really expense and health issue that was created is that they had to replace all of the ductwork. One, they had to replace it because they had to do a whole new load calc once we actually created the right envelope area for the load calc. But there was issues with potential mold and stuff in the ductwork. Like when we were pulling some ceiling tiles, the insulation was literally like pocket dripping water just coming down. Like it was a really bad health situation. And once again, being in this space of weatherization, right, we're used to having that acumen of understanding when we see something like that and the health issues that it can cause. So while this turned into an unrestricted revenue generation opportunity for us as an agency, our building science and our knowledge as a WAP implementer really took that above and beyond to addressing health disparities for people.
And one thing I forgot to mention at the beginning is, especially if you're listening to this after the recording, this is in front of a live audience, but we also have Zay Walter here with us from BPA, who has a microphone. So if any of you have questions, which I'm sure you probably will as we get going with this, feel free to raise your hand, and Zay will bring the mic over to you. That way we can kind of capture what you want to ask and provide an answer to you. Now let me try to think about where I was going to go after that. So one of the problems, so the main problem that was causing this was, right, the bunk room, right? Because, the firemen were getting sick. It was definitely playing a role in their lives and how they feel and how they could do their jobs. But who here lives in a humid environment, deals with a lot of humidity in their market? Okay, so say the homeowner has a house that's dealing with high humidity. What do they usually do? They turn the air conditioning way down, right? Yep. Because when you have high humidity, you gotta drop that temperature to actually make it feel livable, right? So that's exactly what they did in here. Yep. I think what the thermostat was set on, it's like 66 or something.
Yeah,
we got there.
In the winter.
And so what happens when you do that? What happens to the structure when you do that? Things get below dew point. Yep. And if they were already below dew point, now they're way below dew point, and then it just rains harder. And so as you walked around in the building and looked, you could see specific stains. You could see where the sprinkler pipes were running just from where it was dripping above. So it was pretty rough. And the other thing too is when you have, especially an HVAC contractor, come in that doesn't know the house as a system, that doesn't know the stuff we know in weatherization, what do they usually do in that kind of situation? Throw more equipment at it.
Bigger equipment.
Yeah. So they already had two massive systems that were twinned together. And then down the road, they put another 2 tons to serve just the bunk room. So they could get it down to 66. And so, which doesn't work.
And they, in addition to that, they had ducted dehumidification that they added on top of those oversized systems. So they were they were just fighting the outdoors. Basically, they were trying to get rid of latent load from outside. But obviously it was not working for them very well.
So we have a question.
Did you find it helpful working with the fire department? I mean, fire department and weatherization, or fires and weatherization is so similar. Passive air. I'm actually surprised a lot of the firemen weren't able to figure out. They use blower doors to de-smoke houses. Same technology. How'd that go, working with the fire department?
Great question. So when we first did our site walk after making initial contact and making an appointment to go out there and just kind of taking a look around before we proposed, doing a more intensive audit, we had a conversation with the firemen, and the second we started talking about stack effect, they lit up. Yeah. Right. So in particular, we met with the chief and the deputy chief, and the deputy chief said that he's got. The chief kind of picks on him for being, in the weeds on the technical side. So like we hit it off right away, the two of us. But we started talking about stack effect, and he looked over at the chief and he's like, "See, I'm telling you." The chief rolled his eyes, and so it was kind of funny. So. It's a great point. I mean, we're dealing with a lot of the same things. We're trying to manage the same thing when we're talking about air movement or air sealing, right? The fire service is looking at that stuff on a constant basis. Obviously they're looking at it for different reasons, right? We're focused on energy. They're focused on, stopping fire from moving. But the principles are the same. The same, just like we were saying on the weatherization side, working in a small home versus air sealing in a small home on the retrofit side versus air sealing in this kind of commercial setting. It's virtually air sealing is air sealing. You're doing the same thing. You're trying to solve for the same problem. It's just you're solving for it in a different place. So yeah, that was it. It really worked to our benefit, to be honest. Yeah. I think that the deputy chief's nickname was Sheldon. That was perfect.
And so I think that brought up another thing that's important to think about when testing specific commercial buildings is that this is an active fire department.
That's right. Yeah.
Right. So we had to plan for that in our tests. So there were certain doors that we had to leave accessible.
Right.
And the way that the building was laid out, there was, all the fire trucks where they parked was like kind of right in the center. And then one side are the offices, and then the other side is this living quarters where we were testing. And so that was really the only side of the building that we were concerned with. So we had to make sure in our test plan that we leave a pathway so that if a fire alarm goes off and they have to go out, then we have to stay out of the way while still running a 6-fan blower door test. And I think where we're using theatrical fog, we set the fire alarm off at the fire department.
Yeah.
So that happened. There's a video of that.
Trials and tribulations.
Yeah. So it was just part of the job. But so when you're working with multiple fans and manometers and networking them together, it really helps to not only go to the site first and walk it, but get plans of the building so you can use those to draw out, okay, what doors am I going to use to put fans in? How many am I going to put there? If this is a tall building, am I going to need more up top that access the roof? Luckily, this is just a one-story building, so it was pretty straightforward. We just knew it was going to be crazy leaky, so we just kind of guessed about how many fans that we need. But there's actually a calculator you can download from the Retrotec website. It's number of fans calculator, and you can put in the dimensions of the building, what air tightness that you need or what air tightness that you expect, and it'll tell you how many fans you need based on what model that you have. But that's exactly what Dan did. He got plans of that building, and it's like, all right, we're going to put 2 here, 2 here, leave this door open here, put 2 here. So we kind of had them on 3 sides of the building and still was able to leave a pathway so they could get in and out if they needed to. And I think the alarm might have gone off once somewhere where they had to leave and roll out. But yeah, and that might be true for other buildings too. So I've tested government buildings where there was one in New York where it was 1 million square feet of heated floor area. It took up a whole block in New York City. And we could only be there on Saturday and Sunday. So we only had 2 days to figure it out because they opened back up on Monday. So we were working up until maybe 2, 3 in the morning to try to figure out what was going on with it. So when you get into commercial, like planning those out is important. So yeah, safe.
Yeah. So speaking of that, what kind of other, commercial projects do you see opportunities for folks like us to do and make some more money with?
Yeah, that's a good question. Off the top of my head, I think restaurants are a big one because what do they usually have?
flow hoods.
A big exhaust fan, right? Where does that air come from?
Yeah.
Yeah, exactly. Who knows?
Yeah, if they don't have an MUA or a makeup air, then it's just getting pulled in through the building, and they're usually just depressurizing the crap out of those buildings.
Yep.
And have you ever been in a restaurant and it's just like the windows are fogged up?
Mm-hmm.
So we see a lot of that, and it's easy because with our tools, especially if you have a high resolution manometer and like one of our probes that you can use that you can shut under a door, you can see how depressurized the building gets when it's under normal operation. Mm-hmm. And you guys have blower doors. And so you can actually set one of those up and set it to 0 and read what the flow is on channel B. And that's how much makeup air they need. So you can use your blower door as kind of like a powered flow hood to see how much they need. And so I've got at least one HVAC contractor that I've trained on how to do that. And he's eventually got the account for like all the Pizza Huts in Eastern North Carolina, just because he was able to figure that out. But I mean, weatherization people, we know this stuff.
Yeah.
And those are the jobs that pay.
Yep.
I had another one too that was really weird. It was, so I live in Eastern North Carolina. Tobacco is big industry there. And the company that buys it from the farmers, they process it, and then before it goes to get processed into whatever it's going to become, it has to get fumigated. USDA has a certain standard that it has to get fumigated, and I don't know how they measure it, to a certain degree before it goes out, and they test it. And so they put them in these big buildings. A company comes and fumigates it, and then they come and check it. Well, they kept failing their test, and they're like, okay, it's one of two things: either our building is too leaky, or the contractor that's coming to fumigate isn't sealing up the building well enough. And they kind of thought it might have been that, because if it fails, then they have to pay that contractor to come back and do it again. So I went and tested 3 of the buildings, and the one that kept failing was actually the tightest. Because I didn't have anything to go by. The USDA doesn't have any standard for tobacco fumigation chambers. I didn't know what I was really looking for. But I at least could compare the 3 that were there, and the one that they were having problems with was actually the best. So that kind of proved that it was their contractor's fault for not sealing up the buildings well enough. So yeah, you can use blower doors for that. So there's different opportunities out there for sure.
I think the other thing that we realized is that so this builder has built several firehouses in the western suburbs in the Chicagoland area, and so the deputy chief was already telling us, he's like, "Oh yeah, I got a chief buddy over in this suburb, and they've been having similar issues, so they're waiting to see how it shakes out with us. But I think that we're going to connect you guys with them, and you guys go take a look at their project." And so, I mean, I guess a benefit for us is we could just follow this builder around, right? I mean, and just kind of continue to work there. But I think that, something that
knock on the door, like, "How you guys doing?"
Yeah. How you feeling? Yeah. We were over at your buddy's place, and so it's like a bit of it's word of mouth business, and something that I'll pass the mic to John, but he's been really innovative in the way that he's thinking about things, and trying to come up with ways that we can leverage this to actually do more of this work. And
yeah, I think that, sometimes you stumble upon opportunity, but then how do you continue to make it sustainable or capitalize on it? And so this kind of came about last year, but I think we didn't get a submission in time. I was like, hey, we should tell this story, right? And I think that it has a broader benefit than just our organization. We're part of a network that's 1,100 organizations that do this work outside of the market rate contractors. And there's just like an inherent opportunity based on our knowledge. And so we're going to continue to try and tell this story in other spaces, right? We're asking the fire chief, like, hey, what conferences do you guys attend where you talk about your firehouses and these opportunities? And like, Dan, we got to build another presentation. Got to get hold of Sam. And, ABBA is a good place for us to, try and socialize the work that we're doing, right? That audience is automatically going to get it. That could shoot us in the foot because we might create competition in that middle market space, right? But when we talk about those opportunities is Sam and Dan kind of alluded to earlier, a lot of these companies that do this work currently, they're bigger companies, right? They're not taking on that middle market opportunity, the Pizza Huts, if you will, right? Or a 6,000 square foot firehouse. And so, Dan is certainly on our team as we lead to push this forward. The technical guy, I'm more the business guy, looking at what is it going to cost? How can we monetize it? And then how can we create more career paths for employee retention and good company culture, right? So that's kind of our part. I know enough to be dangerous when it comes to the technical side of things. And so I just kind of follow these guys around.
Very dangerous.
And pal around a little bit. So.
Yeah, and I think it also there are a couple of questions, but the one thing I'll say is that I don't know if everybody's familiar with ABBA, the acronym. We're not talking about the band, obviously. We're talking about the Air Barrier Association of America.
Pronounced the same way.
Yeah, and
They sing.
they're the ones that kind of cater to the whole commercial industry on the air barrier side and all the air barrier specific installers, that sort of thing. And they've got the certifications. They even have a blower door certification, so they have the whole building air tightness technician certification, which I think that anybody who's run blower doors and weatherization can qualify for and actually sit and challenge that exam successfully. I did it, and I found it relatively comparable to the all the BPA trainings that we go through and all the blower doors we've run. I mean, our industry, believe it or not, I don't know if many of you realize, but you're running more blower doors probably than anybody else in the country. So leverage that to your benefit for sure.
Yeah. Question.
Can you go specifically into what the scope was, the repairs? Was it on heating systems, shell, what material you used, how much insulation, redefine the thermal envelope? Go into more of the scope.
All right, back to me. Okay. So we tried to, obviously it evolved a little bit, and we were trying to do the simplest application, right? Put a lid on the building, basically. That was the goal. And how do we accomplish that? There's a lot of stuff in the way, a lot of mechanicals, a lot of traffic. There's I-beams, there's all sorts of structural materials. So it was a bit of a challenge, but what we settled on was just putting in a smart membrane, right? So we used, actually, Intello X was the membrane of choice that we used. And that membrane got fastened on the bottom side of that roof truss, basically the ceiling joist all the way throughout the space. And then it got sealed to the exterior block wall with some fluid applied membrane material as well. So that was we used all Proclima products on this. So that was Viscon fiber for making that connection to the wall. And then what they did is they actually fastened on top of the membrane. They fastened some drywall track to help support that membrane, so that perpendicular to the direction that those ceiling joists were running. And then they blew cellulose over the top of that membrane. So essentially, we put a smart membrane up there that provided that air barrier, provided the moisture management as well, and then blew loose insulation on top.
That fire code?
Yeah, so the ACT, the acoustical ceiling tile in that space, was designed to be a rated assembly from the beginning. So that's kind of how they're meeting that requirement.
I have a funny story. Similar situation. I did a fitness center. And they called me in to do an assessment on the fitness center. And I get in and I see up on the ceiling tiles, all these black stains everywhere, all around the place. And there's people exercising on exercise bikes. And I'm like, what are all these stains? I'm like, where's your HVAC unit? The maintenance person, the person walking around is like, I don't really know. I think it's up here somewhere. And I turn the corner and what do I find? A giant indoor pool.
Yeah.
So, and I'm like, okay, well, I'm on to something now. And he's like, I think it's up there. So I get the ladder, I climb up, and there was a giant desert air unit, dehumidifier unit, and the front panel was off and all the wires are coming out. And I says, listen, they brought me there to sell them light bulbs. And I said, listen, I can't sell you any light bulbs. I said, we need to address this health and safety condition first.
Yeah.
So all right, well, we're going to walk you across the street to talk to the executive directors. Like, we've had the roofer out. And they fixed it. I'm like, oh, it's not a roofer problem.
Yep.
So I explained to this woman, I says, listen, what's happening here is that the water's coming off the pool and it's getting through. It was very similar deck, like you said, with the FSK, with the bats sitting right on top, not taped, leaking up, falling down. I says, listen, this wet, moist air is going up and hitting the metal roof and just raining in the attic at all times. And she's like, oh, well, it's the roofer. We called the roofer. I said, it's not the roofer. So then I went home and I was very upset at this point because meanwhile, somebody passed out and the ambulance came and it was like a major health and safety problem at this government funded senior center of sorts. And they wound up, I drew a little diagram with like little rain droplets and the whole 9 yards. And so I called I sent it to her, didn't hear anything for a day or two. I was like, ma'am, I'm just following back up. I was in there doing an assessment and I said, want to find out what you did or what I can do to help more to solve for this problem. She's like, oh, well, I left a message for my roofer.
Yeah.
Yeah.
So it's funny you mentioned that because I left that detail out, but they actually had just spent a ton of money redoing the roof on this building. And part of what they did is they had powered attic fans that they had removed because, initially they had put them in and then they redid the roof. The roofer told me he didn't need it. And they pulled them out and all this other stuff, right? So, but those attic fans were actually just drawing more of that conditioned air up into the attic, right? And so, yeah, a similar story. I mean, they tried literally everything outside of thinking to address the envelope, right? And it was like the simplest solution was right there in front of them, but you just didn't call the right people, I guess. Yeah. So.
Yeah, and I think that's where the conversation, being able to communicate with the customer, and that's what we have.
Yeah.
In weatherization.
Right. I think that's a great point. And like Dan's talking about, when we think about these inherent skills, right, that we possess because we do this work on a daily basis, is we understand work sequencing, right? We understand that if we're going to insulate, when should HVAC go first or second based on what you're going to do. And that really played a big role, Dan did, in working with the contractors, because there was at one point they were going to call the HVAC guy in to run this duct run. And Dan and I are there and we're like, well, how are you can't do that yet, because then how are we going to get above the duct work to install the IntelliBarrier? So it was like, there's other little things, right, that we would assume that a commercial, right, construction company would kind of be on top of. But when you look at things the way that we do in our space, right, the detail, because of how our decisions affect people, I think we have a different detailed perspective, not just about the science, but about the construction.
And how to communicate.
Right. Yeah. And even communicating that to the contractor, the level of detail and what they're actually trying to accomplish, and trying to teach their crew on site how to address these issues. And you're trying to explain, we deal with this challenge all the time in weatherization, but you're trying to explain to somebody the physics of heat transfer and air movement and all these other things. But if they don't have a blower door, if they have no way to induce that, right, you're just talking to them in abstracts. Like these are, oh yeah, sure, they're nodding at you. Oh yeah, okay, yeah, you got it. And then you come back and you run the fan and you do your QC testing and your smoke test. We literally smoke tested every square inch of that install just to verify that, like, and then you come across pinholes, or you come across like tape that was fish mouth, and you come across all these different things that, add up over time, or they sealed everything, but they left this big plumbing wall, a hole in the plumbing wall, and that, and they didn't seal a top plate well, and now there's just all this air rushing through, right? So going through and working with the contractor and trying to explain to them and taking them along with me while I was doing QA/QC testing to really teach them and document everything really well. It was very similar to the work in progress work you do on the weatherization side with crews and contractors. I mean, it's really was no different than any of that stuff that I've done in the past.
Yeah, and one question that I get about this too is like, okay, well, if I'm doing residential, then I get BPI certified, or I become like a ResNet HERS rater. Like, what about commercial? And like, the truth is right now that it's still kind of the Wild West. We talked about ABBA earlier, and they're really the only third party that's offering like a legit certification. We have our own at Retrotec too, because it's kind of a specialized thing. And so we do this 3-day training twice a year where people come out to our headquarters and we really go through the nuts and bolts and everything, and you test the building before you leave. But other than that, there's, whoever's going to be hiring you to do this work, I mean, they don't even really have anything to reference to tell you what you need to have as far as a credential goes, because there's only one and it's still pretty much brand new, and only a handful of people out there have it. So it's just pretty much wide open out there. So if you have the ability to work the equipment, to network multiple fans, to get the results that you need, and the building science knowledge that you already have, I mean, that is a really effective combination.
And the manufacturer really helps out, right? I've had situations where hey, Sam, I've got all this, this building that wants tested. Where can I get these blower doors? Like, I have one, but I think I need 10. Can you tell me how many I need? How can I go about getting them? Like, can I borrow them or?
Yeah, we rent them. We have customers that do that all the time. I mean, sometimes there's 20, 30 fan tests. I think there was one, I think the largest one that's ever been done was, I think it was in Germany. It was a warehouse plant that was like 60 fans or something. So, I mean, yeah, as long as you have the equipment, the people to operate it, and the time to do it, you can do it.
And good internet.
Yeah, and some connectivity for sure.
Yeah, that's the thing too. I mean, we've got plenty of fans, and we're willing to rent them out if we need to, or kind of help out. I mean, honestly, we've gotten
John likes that.
Yeah, we've gotten calls for that in the past. Just kind of cold calls about equipment and that sort of thing. But I think that it kind of goes to build on your point, Dave. Our industry is very willing to collaborate and help each other out, and I think that's really one of the benefits, especially kind of stepping into like this. This mid-market space, if you will. And that's one of the things that I've really enjoyed about it because, literally, Sam, I think we actually got a cold call from this lead. I don't think Sam even called me about it. And then I called him. I was like, hey, we got this lead. Do you know anything about that? And he's like, oh, yeah, I sent that to you. I was like, oh, well, thanks for the heads up. Like, well, can you come help us with it? I mean, and that sort of thing. And, one of the benefits I guess we have as an agency being that we do multifamily work is we have dabbled with kind of larger building tests and running multiple fans and stuff. So, I mean, we may have had just kind of a bit of an advantage over somebody who hasn't done that before. But really, if you can plug in some wires and run a computer software, you can do a multi-fan test because the manufacturers really make it that easy now. Just making sure that, you got some resources to help you walk through the first one and, making sure that you check all your equipment ahead of time. I mean, the planning of these tests really is the key. That's kind of the bigger piece that you need to worry about is planning and just kind of coordination more than anything else.
Yeah, I missed the first few minutes. I was late getting in, but could you go to and speak to the structure of how you got from weatherization at our level to that level of needing 60 fans? And how big of a step is that for an auditing company, a home performance company that uses one fan all the time to go to 2 or 3 fans? And where I'm at in Delaware, we just got an email 2 weeks ago saying they want to start a commercial rebate program. And they want us to come. Anybody who wants to come can get trained, and they're willing to provide equipment and certifications. But they don't even know what they want. They want us to bring this information to them. So how hard is that transition? And you said something about light commercial and commercial. I see that. I envision the light commercial being like doctors' offices and houses that have been changed over to offices from lawyers and doctors and accountants and all. We have a lot of that. We also have data centers, which I was involved in one of them at one time, which is a total mess. But you don't have time to hear that. Could you kind of talk about that transition and how easy or hard that may be?
Yeah, go ahead.
Just real quick, I'll let Sam take that, but I just wanted to mention quickly. So, we did the first test on the firehouse, and again, this is around 6,000 square foot space. And we did the first test with 6 fans, didn't really get a result. We got some numbers, but nothing significant. The last test I did was at the end of March, so they're still working on this project, believe it or not. That's how long it took for the contractor, anyway, so I think that's another conversation we could have. But by that point, all the air barrier had been installed. So this was kind of the last QA/QC test. And they got that. I ran 2 fans only is what I needed to get that test done, and they were at 2,400 CFM at 75 Pascal. So, and that translated based on CFM per square foot about 1.25 or 0.125 CFM per square foot. So really significant decrease. So to answer your question, I mean, a building that size, if in decent condition, or if the air barrier if there's some complete air barrier in place, although not perfect, you probably only need 1 or 2 fans, maybe 2 or 3 fans really to run it. So, I mean, the scaling of what you need equipment wise isn't as significant as needing 60 of them for like a big commercial job.
Yeah, so you're kind of on the right track. That's kind of how I categorize it too. You've got residential, light commercial, and then commercial. And then when you get into full commercial, I mean, it can be a lot of fans, or you're just sampling a tall building on several floors. I mean, that can take quite a while. But if you're working with an organization that wants to do a commercial program like that, I would really want to see what it is that they're trying to achieve. because it's very similar to what we're doing here. Like if they're not doing blower door testing, they're just guessing at what they're trying to do, especially if we're talking about existing buildings. Existing homes, when we do enough of them, they're kind of predictable, but commercial, it could be all over the board. You can't really predict what that's going to be. I mean, there's so many more materials, layouts. I mean, they're usually custom done. I mean, it's a prototype every time. So there's really no telling what you're going to come across. So yeah, we need to test them out. And there's not a whole lot of training opportunities across the country right now that do it. Like I said, ABBA does theirs. They have a few pockets around the country where they do it on the West Coast and the East Coast. They do it in Chicago now too.
They do, yeah.
And then we have ours that we do in Washington State at our headquarters a couple times a year. But other than that, I think the TEC does one too. But other than those three, I mean, that's really the only ones that I know of that are actually teaching it correctly. On how to do it and get the results that you need. So I would go back to that organization and just really try to get a good, clear picture of what it is what they're looking for and what resources that they're using. Because I mean, you could probably help them out quite a bit.
Thank you.
The one other thing I'll mention that I think is there's a builder knowledge gap, I think, on the mechanical side, right? So especially in existing buildings, or even if it's a smaller commercial building but maybe newer construction, understanding the way the mechanical system is functioning in there and the different component pieces sometimes can be a little more complicated than what we're used to seeing in the single family side. Now, if you've done some multifamily work in larger multifamily buildings, it's an easier transition because it's very comparable from that side of things on the HVAC side. But that also is probably maybe like I would say maybe one of the bigger skills gaps that you need to fill in to kind of make the step.
John, give me an idea of like if I'm just an energy auditor, and I'm kind of nervous and I have my own, I'm good at the one blower door. What is it going to take for me to gain the confidence that I need to get to that next level?
Yeah, well, first of all, I think you're gonna have to connect with somebody, right? You're gonna have to connect with somebody that has the knowledge to help train you to build that confidence. I think that's one thing that we have a good ecosystem with at our organization being a little bit larger, right? We have our own dedicated training team. And so our staff can really grow into other areas. I think the fact that we do multifamily, again, to Dan's point, we've taken our residential folks out with our multifamily people and kind of exposed them. And as a matter of fact, I think 3 of our single family energy auditors came out on this project, to get that exposure and help set the fans up. So I think that it's about collaboration and having the right resources to be exposed to the opportunity and to the education.
Sweet.
Yeah.
Any other questions? Comments?
I had a building once, I'll tell another commercial story just for the sake of rounding this thing out. And, one of the good places that I've made some good money is in safe rooms. I know, Sam, you and I have talked about this, being able to get into, a lot of these. I was working for DuPont and a lot of these chemical plants have safe rooms where if everything melts down, the folks working there need to be able to go into their office space, and they use the 1 air change per hour. That's where we were kind of heading down. And, in commercial work, it's way more expensive. The average cost of that test, same amount of time, one blower door tested, just a couple 100 square foot of an office. And I had to come back a couple times because, it wasn't making the grade. It didn't meet the standard that they had. And I was replacing a test that cost 10 times what I was charging, and I was charging a lot. So, there's always that opportunity that, it's hidden places everywhere. Sean, what do you got?
Before you ask that, it's funny when you said safe rooms. I have a customer in Louisiana who also does some testing for those. And actually the manufacturer of the safe rooms for where they use down there is in Houston. And they called our customer and said, hey, we want somebody that can come over to our headquarters and do some testing at our facility to do a tracer gas test. Mm-hmm. And he called me, he goes, what do I do with tracer gas? What do I do with that? So you call them back and tell them it's not 1970 anymore and that you have blower doors that you can do a much better job with. So, because that's exactly what they should be using.
Yep.
So, yeah.
My question is there upgraded commercial blower doors that you offer that are beyond setting up 6 blower doors, using a trailer to back up something a little bigger? As you grow your business, you guys are just starting. But I can see setting up 20 blower doors after a while is going to get tiresome.
Yeah, we have a high output fan that we manufacture. It gives you, so your regular fan will give you about 5,000 CFM. These will give you about 2,000 more per fan. So that's less equipment that you would have to set up. So they run a little bit more. The ones that we have now, they're lighter. They're a DC motor. There's a power supply that sits beside it, but you can get about 8,000 CFM out of one of those at 50 pascals. So that way you're not having to haul as many fans, but you'll still need more than one. There was a company, I think they might still be around, called Infotech, that used to make these big gas-powered trailer fans. Yeah, so Torrance Kramer is like the only person in the country that I know that actually has those. He had 2. He just told me he got another one. I don't know where he got it from. But I really do think he's probably the only person in the United States that has those. They're popular in Europe. They shipped a bunch of them over there a long time ago. But to my knowledge, I don't think they're being manufactured anymore.
I think it also depends on the configuration of the building. So a lot of times, like those would be good in a big open warehouse space. But anytime you've got a building that's divided up that might have, some areas that bottleneck, small hallways, doorways, that sort of thing, it can actually be a challenge if you're putting all the fans in one place, because you won't get balanced pressures then throughout that whole test envelope. So sometimes you have to put fans in one spot and the other spot and kind of spread them out to help make sure that you get consistent pressures throughout the building. So, I mean, there are pros and cons to having one giant setup that can do everything, and then also having kind of, being a little more modular.
So that would be a multi-point low door test.
Yeah, well, so a lot of the standards for commercial are multi-point tests. So you're doing multi-point, but you can still, there are calculations you can do to determine what the bottleneck would be. And if you can open it up, and actually you can still do it as a single zone test, as long as, you can get enough airflow through there and get fans on both sides.
Yeah, so the term that we use, that we want to achieve when we're running the test, is pressure uniformity.
Yep.
Right? I mean, that's true for residential too, right? Before we run the blower door, we open up all the interior doors because they kind of behave like dampers. We don't want to shut off any part of the building. It's the exact same for commercial. So we're propping doors open for stairwells. Sometimes we might be opening up elevator doors if it's multi-story, maybe setting the car on different floors to be able to achieve that. Any way that we can get that pressure uniform all the way. And then sometimes if it's a tall building, like, we put them on the roof if there's a roof access, just to kind of pull it from both sides. So,
and use the fans to move air.
Yeah, using booster fans just to kind of help push it up a staircase maybe, or something like that. So, but that's getting into like full on commercial. If we're talking light commercial, you're probably not going to be getting into that as much. So if this is something you want to pursue, I definitely recommend doing baby steps, right? Start in light commercial, do 2-3 fans, you can practice at your office. You can use the software and try it out, and you don't need a huge space to do it, right? You can take if you have multiple fans, then you can just choke them down to a smaller setting and just kind of force the test to need more, and that way you can network them together and practice.
And it's always better to have a few more fans than you need, rather than try and run a test and not have enough, because it's pretty hard to go back to the shop and regroup all the planning and everything that went into it. So,
So we've got 5 minutes left. I just wanted to leave some time here if you guys had any kind of closing remarks before we take any more questions. And when our time's up at 2:32, we'll hang around here for a sec too if you guys want to come up. So
sure.
John, you want to start?
Sure, yeah. I think that, from the perspective of the opportunity, right? I think that partnership, collaboration, and education, like I said earlier, right? You have to build that social network. I think that it's a very, very obvious that the relationships with the manufacturers of the equipment who provide that training on their equipment was key, specifically in this case. The fact that we really engage heavily with Retrotec is inherent to our success, based on the products they provide us, but more really the friendship and the professional insights that they give us, because without having a relationship with Sam, we wouldn't have had that opportunity, right? And then him spending his time to come out and give us kind of that that confidence and that security of like, hey, we have somebody to lean into from a partnership perspective. So I think it's all about education and partnerships when you're looking to try and, push forward with something innovative or different.
Yeah, and I think, go ahead, Zach.
I was just going to ask, are there any government policies or new codes or things that are coming down the pike that we should be aware of that's going to promulgate a lot more of this work?
You want to take off?
Sure.
You would.
It's very, and John, thanks for the kind words too.
Yeah.
It's very important to you too. So I didn't want to ignore that. It's kind of similar to how residential works. It's all by state, right? So Washington State right now, any commercial building that's being built right now has to be tested. Yeah. Right? They've been kind of the guinea pig in all of this. But in existing, no. Yeah. There's nothing.
Federal? I know there's some federal stuff coming.
There might be, not that I've heard of. You might know more about that than I do.
I just heard it.
Okay, well, so yeah. now I just heard it.
Yeah.
But yeah, I mean, I completely agree though, like with John's point, I mean, about how more that we network together. That's one of the most special things about the people at this conference and just in this industry, because we're all eager to share what we know and help out where we can. The one test I was telling you about earlier, where it took like 30 something fans to test that building in New York, they rented a bunch of fans from us, the customer did, and they got freighted out from our headquarters coming across country to New York. And they told us that it's in Pennsylvania, it'll be there tomorrow. Well, then we found out that no, the truck got stuck in a snowstorm in Wyoming. And there was like 18 fans on that truck. And so I'm at a conference and I had to fly out, and we're on the phone with everybody that we know in New York that has blower doors, and they all showed up and dropped stuff off. And so that was awesome. Yeah. So I mean, like, what other industry can you do that with? So that was a good example of just how we all work together to make stuff happen.
Yeah.
So.
Yeah, I don't think there's any codes. The only thing that I'm aware of that major cities are doing now is they're taking the existing multifamily buildings and they're looking for them to model their energy and then be able to upgrade their energy and giving them a plan. I don't know if that includes any blower doors specifically.
Yeah, that's a good point. I mean, that's kind of that benchmarking process that's going on. A lot of places, Chicago has that as well. But and I'm almost embarrassed to say this, but on the, I think that we all know it, on the weatherization side and multifamily weatherization on large buildings in particular, we're really not doing any blower door testing, right? We're just doing the air sealing work and kind of, it's more of a compartmentalization approach, right? Where we're trying to seal each unit from each unit and then allow the building to kind of continue to do what it's doing in all of the common areas. But on the small multifamily, though, this could be a big opportunity to kind of continue finding ways to, or even just practice your skills, right, and get some of that credibility in this space before moving into the commercial running multiple blower doors. I think that one of the, just kind of as far as final comments and closing thoughts here. One of the things that stood out to me really is as folks that have a lot of experience in this industry, we can't be afraid to leverage that in new ways, and we can't get kind of stuck and entrenched in just looking at it from the one perspective. So I think that was really eye-opening for me, that like, hey, these opportunities exist and they're very attainable. And quite honestly, it's a little intimidating to take on a project like that and doing it for hire and kind of being in a new market. But at the same time, you very quickly realize that you can be just as confident doing that work as you are doing weatherization work. So I think really the challenge I leave with everybody in the room and listening to the podcast is, try and get out there and make sure that people know the work that we're doing and know the skills that we all have in the industry, and that we are credible and capable of doing this testing, especially in the commercial space, because
no one else is doing it.
No one else is doing it.
Nobody else knows it.
And everybody in this room has the expertise to do it, I'm pretty sure. So that's really the thing that I want to leave everybody with.
Cool. We hit it right at 2:30 on the dot. So if you came in late, this is a live episode of the Flow Lab, which is a podcast hosted by Retrotec. We appreciate you guys joining us, and we'll hang out here for a few minutes if you wanted to come up, chat, and ask any questions. Thanks again. Appreciate it.
Thanks, everybody.
Thank you, everybody.